Hello everyone, welcome to the channel Physics Fun. So I've come up with a very amazing problem that is one of the questions of 200 amazing problems of physics. And there is nothing hi-fi about that problem. It's a very good candidate for Jeeadvanced, and this could be my prediction that in Jeeadvanced 2022 this problem might be coming, right? So you might see this problem in Jeeadvanced 2022. Why I'm telling that this is such an amazing problem? Because in this problem, we are going to use the concepts of maths, and in physics, we are going to use the concept of projectile motion, and then we are going to use the concept of geometrical optics, right? So let us straight away go to the problem and see. So there's the problem statement. Problem statement is that the trajectory of a projectile with initial speed v0 is parabolic in a vacuum, right? On the moon, how far is the focus of this parabola from the launch point, right? So it looks like a maths question. So this question can come in maths and physics both, right? So what initial angle of elevation, that means angle of projection of the projectile, is needed if focus is to be at the same altitude as the launch point, right? So if you have understood the question, you can go ahead and listen to me. Otherwise, you can pause the video and read the question once again. Try this question, right? So what all concepts we are going to use here? One very simple concept is that the parabolic shape is the perfect reflector, right? If any light ray is incident parallel to the axis, then it will pass through the focal point of parabola. What does it mean? It means that suppose this is parabola, and then all of you know parabola because all of you are studying maths also. If there is a light ray which comes like this, then somewhere here we will have normal, and after reflection, this is incident ray. So I will mark this as, I will say this as IR, and this is reflected ray, where from which point this reflected ray will pass. This point is called focal point of parabola, right? So this light ray can incident here, you can see, or it can incident here, right? So if I draw another light ray, which is incident and parallel to the optical axis, that light ray is also going to pass the focal point of parabola. So there is no such condition, right? That this angle of incidence would be small and all, because in geometrical optics, we study that spherical mirrors, right? They work best if rays are paraxial rays, right? If angle of incidence is very, very small, right? But no such condition for parabolic reflectors. So you can have a light ray here or here. It might be very close to the optical axis, or it might be very far from the optical axis also. So that is why the word perfect reflector, right? So see, now this is a question of projectile motion, right? But here, the concept which you are using is of geometrical optics, right? So that's the beauty. Let us now see the solution. Okay. So here, this is the projectile, right? You have to see where I'm pointing. This is the projectile. And this is the tangent at initial point. Fine. So I'm assuming that this angle is theta. Okay. So if this angle is theta, then that makes this angle also as theta, right? And this is the line which is perpendicular. Correct? What is the question? The question is, how far is the focus of this parabola from the launch point? So that means we need to find, let us say this point is O. This is parabola, right? Trajectory of the projectile is parabolic. We know this. Let us say this is the focal point. So what distance we need to find out? We need to find the distance OF. That is what we need to calculate, right? So let us see how we are going to calculate this. So here this angle is theta. So let us say there is one light ray, right, which is along y-axis. So this light ray is along y-axis. Then this is the normal. What is angle of incidence? Angle of incidence is going to be 90 minus theta, right? You agree? And since parabola is a perfect reflector, this is incident ray, then reflected ray is going to pass through the focus. And we also know angle of incidence is angle of reflection. So that makes this angle also as, I'm writing here, see very carefully. So at the end of this video, you will thank me, you will learn a very amazing concept, very, very amazing concept. So this is 90 minus theta, this is 90 minus theta, right? And what else? See, if this angle is 90 minus theta, that makes this angle as theta, isn't it? So this angle then will become 90 minus 2 theta. That makes this angle as 2 theta. Isn't it? Any doubt in this, right? What is it we want to find out? This distance is OF, right? We want to find out OF distance, correct? To find out OF distance, now I am marking one more point. Let us say this point is OA, right? So can I write OF? Question is solved, right? You can pause the video here and solve it now by yourself. OF sine 2 theta is going to be equal to what? OA. And what is OA? OA is the half of the range, right? So OF, which is this, that we need to find out. So OF is into sine 2 theta. What is OA? Half of the range. Half of the range is range formula. U squared sine 2 theta by G, right? Here, see, what is the angle of projection here with the horizontal? It's 90 minus theta, right? Not theta. Angle of projection is 90. As I have assumed, you have to be very careful. I have assumed this angle is theta, right? So angle of projection is 90 minus theta. But if you write range formula, I'm going to write here, range formula is 2 ux uy by g, right? What is ux? You can write this as u cos theta and u sine theta divided by g. U square sine, sorry, u square sine, or sorry, it was correct earlier, 2 u cos theta, u sine theta. So if you write theta or 90 minus theta, they're complementary angle. You know that complementary angle gives the same range. So here, what I'm going to use now, this formula of range. So 2u square cos theta sine theta divided by 2g, right? Why 2 here? Because this is half of the range. Now see, this is the magic, sine 2 theta cancels. This is sine 2 theta, and OF is now equal to what? U square by 2g. That's it. That's the answer. Right? Isn't it amazing? This is the answer. So the distance of launch point, right, and distance between launch point and focal point of the parabola is independent of the launch angle. Right? If you remember this point, you might get exact same question in Jeeadvanced, or you might get a question in which you might have to use this point, right? Question might become very simple if you just remember this point. Okay, so it's better to remember this. Launch point to focus point, it's just u square by 2g. It is independent of the angle of projection. Fine. So second point, now you can point you can solve by yourself. Just for completion, I will do that also. What initial angle of elevation of the projectile is needed if focus is to be at the same altitude as the launch point, right? So you want focus to come where? Here, right? Same altitude. So if you want focus to come here, then how much should be 2 theta? 2 theta should be equal to, this is B part. Guess now, apply the logic. What is 2 theta? 2 theta is equal to 90 degree, theta is equal to 45 degree. Right, so that's it. That's the analysis. You've learned such an amazing concept. If this question can come in maths also, physics also. In physics also, 2 chapters we are using, right? So very, very probable question of Jeeadvanced, right? Okay, thank you very much. If you have liked this analysis, if you have learned something new, then you can help me by liking this video and sharing this with your friend. Thank you very much. Thanks for watching. We'll meet again. Thank you.